Okay, in this lesson we're going to have a look at substitution into algebraic expressions. So the target is to understand that. We're going to do that by being able to substitute numbers into expressions and then to use our knowledge of BODMAS or order of operations in order to actually then correctly calculate the number part of it. So substitution, what is it? Well, you know perhaps some ideas about mathematical formulae. A formula is a rule. Well, the good news is that if you've ever worked out the area of a rectangle using this formula, area equals length times width, then you've already used substitution, because all the formula does is it gives us some letters to represent quantities, and if we know some of those actual quantities in our particular case, then we can swap the numbers in. When we swap the numbers in, we are substituting. That's what to substitute means. It means to swap, like in a football match. So here, if that's A for area, remember, oops, I'll bet my A is area, and L is length, and B is breadth. Then if we want to work out the area of this rectangle, then we can swap in L, the length is say 5 here, so we could put 5 in, the breadth is 9, and the X sign, the multiplication sign, reminds us what to do with those two numbers. 5 multiplied by 9 is 45, and we can say the area there is 45 square centimetres. All we've really done is we've taken an algebraic expression, this time called a formula, and we've said we're going to swap in the number 5 for L, and we're going to swap in the number 9 for B, and then we do the number part. Okay. Another way of thinking about algebraic expressions is to think about function machines, and we've already come across these things, hopefully you have. And we started off thinking about these with numbers. I'm just going to quickly remind you that when we've got a situation where, so we put the number 3 in, and the function machine tells us what to do when we put a number in. So if 3 goes into this function, it says add 5, then what we get out is, of course, is 3 add 5, which is 8. And if we put the number 12 into the second function, then the instruction is divide by 3, then in fact the answer is 12 divided by 3, which is 4. 4 comes out. Okay, there might be a two-step function. If we put to the number 4 in, the instruction says multiply by 4. So 4 times 4 is 16 at that point. Then we put 16 into the second part of it and it says subtract 2. So 16 subtract 2 is 14. So 14 would be the result of that function. And we might even get an instruction, say like to multiply by itself. So say 5 goes into this function, it says multiply by itself. 5 multiplied by 5 is 25, or squaring, we might say. So these are what we do with numbers. Let's have a wee think briefly about what happens with the letters. So let's just put these back on again, and we know that if we put a letter in instead, we can't work out a numerical value. Okay, so what I'm going to do is I'm going to stick in, let me make it red here, I'm going to stick in the letter A, okay, instead of 3. Now we don't have a numerical value for A, so we can't just say A plus 5 equals some number value. All we can do is to say A add 5, we can write down as A plus 5. So when you see algebraic expressions like this, A plus 5, just remember that it's the idea of saying we take a number and we add 5 to it. What is it? Okay, if you imagine it as a function machine, it might help. Say we take the letter C and we put it into this function. It says divide by 3. On the left hand side we had 12 divided by 3. Do you notice that I wrote it like that when I did the calculation? So we could actually write that expression as C over 3, or we could just write it as C divided by 3. Again, we can't work out a numerical value because we don't know what the number of C is. So that's a good way to represent C divided by 3, is just write it C over 3. But remember, you could redraw or you could think about that function whenever you see a fraction like that. When it comes to two-step function machines, say we had the letter n at the beginning to represent some number. So if we say n goes in and it says multiplied by 4, what comes out of that? Well, 4 multiplied by n, the shortcut for that is 4n. Just put the two terms together, two number and letter together, 4n. Then it says subtract 2. The only way we can write that down is 4n, 4 multiplied by n, subtract 2, and that's our expression. So 4n minus 2 means a number goes in, it multiplies by 4, and then we subtract 2. So if you can make that connection between the algebraic form of it and the picture form, that'd be really good. And the last one here, if we say the letter T goes in, I could use any letter for here. I've changed them around. It could always be X or it could always be A, or doesn't matter. I like to change it around. If we've got T and we say multiply T by itself, T times T, we could write it like that. Or the shortcut way of doing it, hopefully you've come across that before, is just T squared, multiply it by itself. Okay, so that's just a bit of background. What I want to do is help you understand then that when we come across expressions like this, we're going to substitute, that you don't think, well, this is a kind of weird thing, I don't know what that means. So this example says, find the value of these expressions when a is equal to 8. Okay, so a plus 3 is our expression. That could as well have been a function machine that says, here's the letter a, and the instruction is add 3. Okay, but we don't always need to draw a function machine. If you're confident about what that means, it simply means to swap in a for the number 8, because we're told that a has the value of 8. So we swap in 8 anytime you see the letter a, and then we do the resulting arithmetic. 8 add 3 is of course 11. Now it's really important that you spend a wee bit of time. You could do it in your head. You could just visualize a is 8, add 3, and write down the number 11. But I want you always to write down that line where you swap the letter for the number. Okay. Secondly, here's 2a. Now we know that there's no sign in between these terms, and in algebra, when there's no operation sign, it's a hidden multiplication. So that becomes 2 multiplied by the value of a, which is 8. 2 multiplied by 8 is 16. What about this one down here? 3a over 4. 3a divided by 4. Remember that line's a division sign? Well, there's two things going on. The first thing I have to remember is we've got 3 here. So we've got 3 multiplied by a, which is still 8, divided by 4. Okay, we don't do any calculations until we write it all out with numbers. And then we can go ahead. Now, because there's a calculation itself on the top, I'm not going to write down the answer. I'm just going to write down the answer to that top line, the numerator, and still remind myself that I have to divide by 4. 24 divided by 4 is 6. Okay, so take your time, and no prizes for rushing and making a mistake. And in D, we've got the expression a squared. Well, we saw back on the previous page that the square one would be a, and basically multiplied by itself. Okay, so that would be a multiplied by a, or a squared. So all we need to do when we simplify or substitute, a squared is a is 8. Now you can either just write this symbol in there if you are happy with that, or what you could do is just go for the full 8 multiplied by 8. Either way, the answer is 64. Okay, so there's effectively at least 3 lines of work in your simplifying. First of all, you write down the expression that you're given. The second line, you swap in the number that you're given, and if there's nothing else you need to do, the third line is the answer. Sometimes you might find there's the second stage, there's a few lines, okay, until you get to the answer. But it's really important that you communicate what it is you're doing all the time. So I've got here on the next page is I've got some questions I'd like you to attempt. I want you to pause the video, and I want you to set them out as I have done, and then I'm going to go over the answers once you unpause the video. Okay, so pause the video now, and in your jotter, work through these substitution problems. Okay, so what we're going to do is just go over the answers. I've got some already written down here. So just take a moment to correct your work and check that your work looks like mine. Okay, so I'm going to just go over a few of the later ones just because they're a wee bit trickier. So in I, it says 7x divided by 2. There's the division sign, or you might find sometimes you might like just to do that and write it as a fraction. Either way, it doesn't matter. So it means you get 7 times x, so 7 multiplied by x is 4, divided by 2. I'll just write it down as it's written there. So the order of operations say that multiplying and dividing are equally important, so we don't do the dividing bit first. We just go ahead. 7 multiplied by 4 is 28, and divided by 2, and we get the answer 14. Okay, so the order of operations hasn't really come into play at the moment. We haven't found anything that's more important. It's either always, we've got multiplying ones here. Let's have a look at J. We've got 4xy divided by 6. So that's 4 multiplied by x is 4, y is 3, and we have to divide our answer by 6. Okay, so there's nothing more important, multiplying and dividing. So because they're the same, we do it from left to right. 4 times 4 is 16, and 16 multiplied by 3 is 48. So I'm going to do that, and then I'm going to write down my divided by 6. And 48 divided by 6 is 8. Okay, k, xy divided by 10. xy, there's no sign between them, so remember that's multiplying. So x is 4, multiplied by y is 3, divided by 10. Again, order of operations, there's no difference. So we start from the left-hand side. 4 3s are 12, divided by 10. Well, I can't do that and get a whole number because it's I can multiply or divide by 10, move everything down one place value, we would get the answer 1.2, or I could write my answer as 12 over 10, which is the same as 6 over 5, but I'll go with 1.2 here. And finally, x plus y over 7, there's a fraction in here, so if x is 4 plus y is 3, divided by 7, do the top calculation first. 7 divided by 7 is equal to 1. Okay, so hopefully you got them right. If so, great. All right, I'm going to give you another set of questions to do. Okay, and I want you to see how you get on with these. Again, I'll go over some of the answers, but this time the values of P and Q are 6 and 8. And this time you're going to need to work out your order of operations, okay, really carefully, particularly C. So just watch these. So I want you to pause the video and you can then watch the answers that I've got and we can compare, okay? So pause the video just now and have a go at these questions. Okay, so hopefully you had a go at some of these at least, or you're going to wait and get a wee bit of a hand here. So answers wise, here's the first few. And the kind of order of operations really kicks in, particularly in C here, because you get 20 minus 3 multiplied by 6. Now, what I want to do is show you a little feature here that I've introduced, because instead of putting a multiplication sign, I've actually put the substituted number in a bracket. And in mathematics, when you've got a number in front of a bracket, you multiply. Okay, so it's a way of reducing the number of x's around the place, and it means automatically that you're going to multiply. So I decided in this set of examples to use the brackets, but if you want to keep using the multiplication symbol, that's absolutely fine. So if you notice in C here, we've got 20 minus 3 times 6. So we can't do 20 take away 3 is 17 and then multiply by 6, okay? Which is why the bracket thing's quite good, because it keeps the 3 really close to the 6 and reminds you that you have to do that first. Okay, so 3 6s are 18. We do that first. 20 subtract 18 is 2. Okay, so here's those answers. Let's just work through quickly with me on these ones here. So you've got E is 12 minus 1.5 multiplied by q. So again, I'm going to put my bracket after 1.5. I can put an empty bracket, and then I can look at for q and say it's 8, and so I stick 8 in there. Now, order of operations, they do the multiplying before the subtracting. 1.5 times 8, you might want to do a calculation for that. 8 times 5 is 40, carry the 4, 8 times 1 is 8, plus the 4 is 12. The answer is not 120. It has to be 8 times 1 is 8, so it's a number, put a decimal point in close to the number 8. So I'm going to get 12, that's fine. There's mental strategies for that as well. So we're going to get 12 as our answer, and look, 12 subtract 12 is 0. Okay, let's have a look at f. We've got our fraction multiplier, a half p plus 7. So instead of the letter, I'm going to put an empty bracket. And p is the number 6, so I swap that in there. And a half multiplied by 6, a half of 6 is 3. 3 plus 7 is equal to 10. The other thing about putting the brackets in, so in G we've got a quarter Q minus 1, is that you can actually rewrite the whole expression, and any time there's a letter you put a bracket in, and you can do the whole expression before you actually put the number, swap the number in, and it kind of reminds you of all the things that stay the same. So we've got Q is 8, so I'm going to drop 8 into the bracket instead of Q. A quarter of 8 is 2. 2 subtract 1 is 1. Okay, H is P squared. That's quite straightforward because I know that P is 6, and I know that the square means multiply it by itself, so the answer is 36. And in the same way, Q squared, I could write it like this. 8 is my bracket. Again, 8 squared is 64. Okay, then we're going to use the squared terms. P squared over 4. Well, you know what, you could argue and say, well, I already know that p squared is 36. I could put that straight in. You could do, but I'm just going to keep telling the story and say 6 squared over 4 is 36 over 4, which is 9. HIK. Here we go. Q squared over 64. Again, Q is 8, so I'm going to put 8 squared over 64, which is 64 divided by 64, which is 1. Hopefully you got that. And finally, 96 divided by PQ. What does that mean? PQ means P multiplied by Q. So you could put some brackets in like that and say 6 and 8. We know that 8 times 6 is 48, and 96 divided by 48. You notice that 2 times 48 is 96. So in other words, the answer is 2. Okay, so hopefully you got them, or you've come because you got stuck, and then you can go back a little bit in time when the answers aren't there. You can have a go at doing these. Okay, so that's our first lesson on substitution. Hopefully that's something that's quite you're kind of getting the idea of, and if in doubt, you can always draw a bit of a function machine. You can use the brackets if you think that helps you, and hopefully you've got an idea now about substitution.